All righty, folks. Good to see you all again. We're going to keep going through looking at trig proofs just a little bit more. And so that way we kind of recall, remember that we essentially have three different steps, or three different things we're looking for. Let's see if we can't get those back out there again. Three keys to verifying identities, or verifying trig proofs. Verifying proofs, there we go. So the first thing we said is pick the uglier side, and that's usually the side with more stuff. All right, usually the side with more stuff, and make it identical to the other side. We had a little key on this. The biggest thing, if you guys remember this as well, we said, hey, you can only play with one side. So you can only do one side. So pick the uglier side, since that's the one side you can do, and then just go to town on it. The second thing we said to do is, if you ever get in doubt or trouble, turn everything into sine and cosine. And then our third thing that we said that we can do when we're dealing with proofs is we're using essentially two sets of operations. The first thing we have is you could be doing any trig identity substitution. So look for those trig identities. See if you can't put any in there. Other things after that, algebra. Use algebra. And with algebra, don't forget to factor. Don't forget to get common denominators. Don't forget to multiply by conjugates. And again, just other different types of things you possibly could do. So that's essentially kind of what we're looking at on these things, is trying to figure out how do we go through and clean up a lot of these to make them a little bit more. So we have a couple identities here, and I'm going to actually erase those here because I want to walk through them from scratch. I know that they're on your guys' notes, but I kind of want to go through them from scratch just so we're all kind of on the same page here. So again, you have these in front of you, so it's not that big a deal, but I do want to just make sure that we're all kind of on the same page so we all kind of have an idea what we're looking at. So we start off here, we have an easier one, secant x cosine x. So there are no sides on this one, it's just verifying an identity. There are no sides, so we just deal with the one thing we have. So secant x cosine x, you'd be looking at it and say, okay, well, there's nothing I can do as far as algebra is concerned. So is there some sort of trig identity? In which case there was. We can change secant x into 1 over cosine x times cosine x. And so on your notes, you guys are kind of following along. These are kind of the things we're looking at here as you're going through and dealing with these. So secant x, cosine x. So we change one of them. And I could have changed cosine x into 1 over secant x just as easy. And so this is the same thing as being over 1. So we end up with cosine x over cosine x, which is equal to 1. So we're just looking for what can we do? What things can we kind of clean up? On the other one that I just blocked off here, we have cosecant squared x. Minus cosine squared x. cosecant squared x. So I could be looking at these cosecants and see them as 1 over sine. It wouldn't necessarily help me out a whole heck of a lot, but what I could always look to do then is potentially factor it. So we think this time maybe a trig substitution doesn't work. So then we start thinking about factoring. Is there some way I can factor it to kind of clean it up a little bit? And I end up with 1 minus cosine squared x. So if we factored out that cosecant squared x, we'd be left with 1 minus cosine squared x. And so we start thinking about cosine squared x. Well, it's a square, so it's one of my Pythagorean triples. And the Pythagorean triple, the Pythagorean identity that had cosine in it, was sine squared x plus cosine squared x equals 1. So I can create this identity that's left in the parentheses by just subtracting cosine squared over to the other side. And I'd end up with sine squared x equals 1 minus cosine squared x. So if we do go ahead and enter in that trig substitution. So notice I started with algebra when I factored, and now I'm doing a trig substitution using one of my trig identities. So cosine squared x, again, that would be another trig identity. I can go and turn that into 1 over sine squared x. So we're going to multiply that by sine squared x. So 1 over sine squared x times sine squared x. So we leave trig again. We go back to algebra. We multiply those together, and we end up with 1. And again, that's what you see on your notes there. That's what we just blocked off. But again, I think it's good for us to talk it through before we actually go through and do a few more of these. So we're going to try a few more of these here as we work our way through. It's kind of day 3 of our practice. So let's see how you guys kind of hold up on this. All right, here we go. Let me go ahead and get rid of this here real quick. Let's see here, clear drawings. Whoop. All right, so we start off. We're going to pick the uglier side. What is the uglier side? So I have 1 minus 2 sine squared theta equals 2 cosine squared theta. And again, I don't think either of these is any easier, uglier than the other one. So I'm going to actually end up solving it both ways, because it all depends on what way you decide to do. If you think the left side is a side you want to play with, then you go for it. If you think the right side, the cosine way, is a little bit easier, then go for that. All right, but pick one side and go to town. So friends, go ahead and take a second here, see what you guys can deal with that, and we will meet back here in about 2 minutes after you're done, and give it a shot. All right, friends. So you guys all started off with, most likely, hopefully, you saw the sine squared plus, or in the cosine squared, so you went to that Pythagorean identity. My handwriting apparently is not very good here on this one. So if I wanted sine squared to be by itself, I'd move the cosine squared to the other side. So I mean, sine squared theta equals 1 minus cosine squared theta. Remember, these are the two extra kind of like corollaries of the Pythagorean identities I told you probably want to add to your formula sheet, because we will use these two quite a bit. If you were getting cosine squared by itself, you'd have 1 minus sine squared. So the folks that did the left side, we're going to deal with yours first. So if I'm using the left side, I can only use the left side. I can't do anything else. Can't use the right side at all. So sine squared was 1 minus cosine squared. So I'm going to plug that in there. And we're just looking for how do we make them become identical. Can't touch the right side. Since I'm doing the left, I only get to use the left. So I have 1. I'm going to distribute that 2 in there. So plus 2 cosine squared theta. And we clean it up a little bit, and then all of a sudden we find out that 2 cosine squared theta plus 1 equals 2 cosine squared theta plus 1. So proof is done. We've verified it. Therefore, these two things are the same thing. Later on, we'll find out that they actually are equal to something called a double angle formula. They're both versions of the double angle formula of cosine 2 theta. So when we finish our proof, put a little QED or a little box after the end of it, and you are good. All right, so if I'm dealing with this one, and if you chose to do the right side, that means we're going to leave this left side alone. We're not going to touch it. And in place of that cosine, then I would have plugged in 1 minus sine squared theta. And again, we did our trig substitution. Now we're going to do a little bit of algebra to clean it up. And notice, again, I picked one side and I'm staying with that one side. I don't get to use the left side. If I'm going to manipulate the right side, I don't get to use the left side. And on top of that, notice how I'm still writing the other side all the way down. I got to make sure my form is right. Got to keep writing the side that I'm not using. I keep bringing that down with me all the way. So 2 sine squared theta equals 1 minus 2 sine squared theta. And we are done. All right. Well, friends, why don't you guys try that number 4 there, and then we will spend a little time talking about it. Go for it. All right. So I look at this one here, and to me, it's one of those that, again, I know which one I find to be more the uglier side. That doesn't mean that everybody finds the same thing. Even though the right side has got an uglier fraction, the left side has 2 fractions. And since there's more fractions there, that means there's more stuff for me to be able to manipulate. And the whole point is there enough stuff that I can manipulate? If there is, or if there's more stuff that I can manipulate, then I have a better shot of getting everything by itself. So I noticed that on the 1 over sine x and the 1 over cosine x, they have different denominators. So I'm going to multiply by a whole bunch of 1s to get them to have the same denominator. So this one didn't have a cosine x, so I'm going to multiply it by cosine x over cosine x. And again, even though I'm going to multiply the 2 fractions by a different fraction, both these fractions, cosine over cosine, on this one, sine over sine, they both equal 1. So it didn't change the value of the fraction. So we're going to multiply by cosine x over cosine x, and then sine x over sine x. So we end up with cosine x over sine x cosine x minus sine x over sine x cosine x and you can kind of see right now we're just about done. Notice on this one, I ended up not using a single trig identity. Sometimes all you use are trig identities. Sometimes all you use are algebraic operations, and that's okay. So now that they're over the same denominator, I can combine them into one denominator. So cosine x minus sine x all over sine x cosine x. So that left side became equivalent to the right side. All done. All right. Well, let's keep going here. See if we can't look at it maybe a little bit harder, different proofs, as we're just getting more practice at this stuff here. All right, so 1 over sine x plus 1 over cosine x all over. I'm hoping, friends, that you are saying right from the very beginning, the stuff on the left-hand side is the uglier side. Look at, I mean, we have 4 fractions in a fraction. We have a huge complex fraction. I would rather just play with that one real quick. So 1 over sine x plus 1 over cosine x 1 over sine x minus 1 over cosine x. I'm going to make that equal to the other side. All right, so I'm looking to get rid of those denominators. I mean, that's going to be like job number one. Get rid of those denominators so I can start to find things a little bit cleaner to play with. And again, you could do the right side if you wanted to. I'm going to just kind of avoid it because I got multiple fractions I can play with here, which makes that a little bit easier. So I'm going to multiply by the common denominator. So I'm going to multiply by sine x cosine x. And since I multiplied the top by sine x cosine x and the bottom, I'm really multiplying by just 1. So every fraction is going to be multiplied by that same thing, which means I'm multiplying by sine x cosine x over sine x cosine x. I'm multiplying by 1. So we're going through here. I'm going to multiply every single thing by it. And when I do that, I see sine x's cancel out here. Cosines would go away here. Cosines here, and sines would go away there. So that would leave me then with cosine x plus sine x all over cosine x minus sine x. And I'm going to take a quick little second here. I'm going to go off to the side here. I'm going to show you what I see. And because sometimes you're looking for little context clues again to try to help you out. So one of the things I'm looking at is my numerators. I notice here I have cosine x plus sine x. Over here I have cosine squared minus sine squared. So eventually at some point in time, I have to figure out how do I make those show up. Well, if I looked at cosine squared minus sine squared, I have what I'm really looking at there is the difference of two squares. So if I were to think of it algebraically, that's the difference of two squares. It means it's the same thing as cosine x minus sine x times cosine x plus sine x. So I know that if I were to multiply cosine x plus sine x, if I were to multiply the numerator on the left, if I were to multiply this by cosine x minus sine x, I could create the numerator on the other side. But if I do it to the top, that means I also need to do it to the bottom. So we can do that, cosine x minus sine x. So I know that I'm going to pretty much have my numerator all nailed out. I'll have to keep working on manipulating the denominator a little bit, but it should hopefully fall into place here pretty quick. So cosine squared x minus sine squared x. And then down at the bottom, I have cosine squared x minus 2 sine x cosine x. So that's got that 2 cosine x sine x I needed. Plus sine squared x. And if you notice, friends, all we're doing here so far, this is primarily just algebra. Now we're using trig functions, but we're really just doing algebra. Do we recognize things? I've yet to do a single trig identity. Now that's going to change here in a second. All right, so the numerator is good. I'm looking at the denominator. And on my denominator, I see a cosine squared x. I see a sine squared x. So if I ever can remember that cosine squared x plus sine squared x, I can remember those two. I can remember that they actually are one of my Pythagorean identities again. It's one I use most often, that equals 1. So I'm going to rewrite that real quick to get those two together. I don't have to, but I think it makes it a little bit easier to see. So, oops, that x got a little bit away from me. So cosine squared x plus sine squared x minus 2 cosine x sine x. And that whole thing is still equal to cosine squared x minus sine squared x. You just got to keep writing it over and over and over again. Luckily, I'm only going to have to write it one more time, because I believe that this proof is just about done. So cosine squared x plus sine squared x, that whole thing is going to be equal to 1. So now I can make that final substitution, and we can call this thing a day. And friends, I believe we have this proof done. So we got a couple more that we're going to do here, and then we'll call this video. So the left side became the right side. And to show that we're done, a little red box there. Oh, that was a circle. I don't want a circle. I want a box. Or you can write the QED. All right. So if you look at it, cosine x tan x plus 2 cosine x minus tan x minus 2. Holy wow, that's a big problem. Why don't you guys go ahead and pause the video and see if you guys can't take a little chance at number 6, and then we'll come back and take a look at it. All right, well, I'll tell you what. When I looked at this thing, I see 1 term, 2 terms, 3 terms, and 4 terms. So that tells me that when I see something like that, I'm probably going to go back and deal with factoring. I'll show you that here in a second. So cosine x, tan x, I got to first write the problem, plus 2 cosine x minus tangent of x minus 2 all over tan x plus 2 equals cosine x minus 1. So if it were me, I'd come over here to this other side and I'd go, all right, I see 4 terms in the numerator. We're going to go back to an oldie but a goodie, a little generic rectangle here, friends. You know how much I love drawing generic rectangles. But when there are 4 terms, I'll be honest, I think it's actually kind of nice. So what do I were to take those 4 terms in the numerator and put them into a generic rectangle? Again, I'm just doing algebra. It's either a trig identity or algebra 1. So I'm just doing some algebra, throwing everything in here. And now I'm looking for my greatest common factors. So let's see here, cosine x, tangent x, they look like they have a cosine x in common. Tan x, negative 2, that's nothing in common, so they get a negative 1. I have a tangent of x up here, and a positive 2. So that means the numerator is going to factor to cosine x minus 1. And tan x plus 2. And then from there, friends, just a real quick kind of cancel out of the common term here, in which case the tan x plus 2's go away. Oops. If you notice, again, we had a problem that involved really no trig substitutions. It was really nothing more than just algebra. We'll use the occasional trig substitution if we have to, but majority of these are just algebra. All right, and friends, I'm going to have one more proof for you guys to try here, and we'll call it a day. So if you look at that number 7 right there, go ahead and give that one a shot. Pause the video, give it a shot, see what you guys can deal with, and then we'll come back and take a look at it. All right, take care. All right, friends. First of all, again, I got to write out the whole thing. Holy wow. Not looking forward to playing with that one, I don't think. Maybe it'll be okay. We'll find out. We'll find out. First glance, I got all kinds of stuff going on here. I'm hoping you guys can tell which side's the uglier side. I got fractions and fractions. I got 3 terms in the numerator. I got 2 in the denominator. This left side, in my mind, I am going to make that the, by far, I'm going to make that one the ugly side. So I'll play with the left side as I go through and do it with this one. Yeah, actually, I probably want to make this just a little bit bigger here. There we are. So minus 2 plus 1 over sine x. Equals sine x minus 1, sine x plus 1. All right, friends. So when I'm looking at this here, I do see all those denominators. So I'm going to multiply everything by that common denominator. So my denominator is sine. So all 5 terms I'm going to multiply by sine. So what I'm really multiplying by is sine x over sine x, which is just 1. I'm not altering the value of that left side, so I'm only multiplying it by 1. So I'm not going to do anything with that right side. I'm going to leave it alone. I can only touch one side. So everybody gets to be multiplied by sine x. So I end up here then with sine squared x minus 2 sine x plus 1 all over sine squared x minus 1. So I got a quadratic on top and I got a quadratic on the bottom. So I'm going to end up doing some factoring. So essentially what I'm looking at here, friends, is I'm going to be trying to figure out how to factor this. So sine squared x minus 2 sine x plus 1. So I go here, I see that's pretty much a perfect squared trinomial. So that'd be like the same thing as sine minus 1, sine minus 1. So I'm going to, or s minus 1. I usually, sometimes when I'm factoring, friends, I'll just go off to the side there and I just treat it like I did back in algebra. So instead of calling it sine, I just called it s. Instead of calling it cosine, I call it c. And I just try to manipulate it on the left side so I know how it factors. That's difference in squares there. So then when I come back into my trig proof over here, I know kind of what I'm looking at here. So this is sine x minus 1. So I have a, on top I have a perfect squared trinomial. And in my numerator, I have the difference of squares. And that would be equal to the right side. So at that point in time, I can look to cancel out my common factor here, friends, and whoop, whoop. And when we do that, we end up getting the same thing. And if you notice, again, there was no trig on this particular one. It was all algebra. We'll use the trig identities when we have to, but pretty much these are going to be primarily algebra. All right, friends, and that pretty much brings us to a close. So go ahead and we add ourselves in our red box there. Now we can call it a day. All right. Keep working on you guys' trig proofs. I'll see you guys in class, and we'll spend a little bit more time talking about this. All right. Have a good rest of the day.